Welcome back, and today we're going to look at some pathfinding. So if you're doing the OCR or AQA A-level, you'll have heard about A-star and Dijkstra's pathfinding algorithms. If you've just looked at any sort of general game development things, you'll have heard of A-star before. So we're going to look at how we can easily implement them into our P5 play games, and this can be easily used in P5 as well. So let's get into it. So the first thing we're going to do is, as I said, I'm going to do it in P5 Play, so I need to get the P5 Play library up so I can get onto here. All of your learning and things should be on this website anyway. All the bits are in there that you need. I'm going to copy and paste the local development, go into here and replace this. Now if you are using like VS Code or something, I am going to do a separate video on this, so it might already be up by now, who knows. But you don't have to use Replit, I'm just using it because that's what I use at work. And let's get rid of all of this stuff that we don't need, and we can start. So the first thing we need, if we look for pathfinding.js, I've already got it set in my search history, we've got this here, where we can go ahead and just download these as you would normally. I've already got them downloaded. Just make sure you've got that downloaded and uploaded to your project. So you see I've got mine there. Clearly I've downloaded way too many of this library because it says the wrong thing. So there we go, that's in there now. And then in my index, just as you would anything else, you just need to make sure that you have got your script in there. So I can just put that in there like that. So now I've got pathfinder browser min.js, which is that there. And that's it. We can start doing some actual pathfinding now. So if you've got like a maze game, you want to solve the maze, or you're being chased throughout a level, this is a really good algorithm to use. If you're in like a platform game, it doesn't work as well because ideally you sort of need like a contained area. I used it in my racing game tutorial. I've used it in tower defense. And I'm going to do a couple of videos on this pathfinding library, so you will be able to sort of see some applications. So we'll start off nice and simple with just getting it navigating a maze, and then in later videos we'll look at how we could maybe get like a sprite chasing another sprite and doing something like that. So let's get started. So first things first, I'm going to need a bunch of different variables. So I'm going to start off with path, which is going to be the path that we pathfind on. The grid, which is going to be our matrix, essentially, that is going to be outputted from the library, which is going to allow the path to be made. And then node is an object I'm going to use later on. And then I want moving sprite, that's going to be our moving sprite, believe it or not. And then there's a few other variables I need, which I'll come to later on. So first things first, we'll start off nice and easy and make a sprite. If you haven't looked at a tutorial on P5 Play before, this doesn't have to be a P5 Play sprite. This could be an object you make yourself. It's entirely up to you. So I'm going to do moving sprite equals a new sprite, like that. So if you just have that first, get it running, fingers crossed there's no errors or anything, you'll have a square in the middle, you know you're on the right lines. And then I'm just going to make it into a circle, so I'm going to say moving sprite dot radius equals 10, and just to make my life easier, I'm going to give, instead of doing a starting position of X and Y, I'm just going to give it a tile, so I can put it in a tile map nice and easy. And then I need another object to be our wall. I could just use rectangles. I don't necessarily need to use a group or a sprite for that, but for tile mapping you want to use a group, so I am going to do that. So I'm just going to say I'm going to add my wall, so wall there, and I'm going to say wall equals a new group. I'm going to set a tile to be 1, I'll explain that in a moment. And then I think to make things easier, let's just do let tile size equals 50, so that's nice and easy. And I can just do wall dot width equals tile size, wall dot height equals tile size, like that. And then I'm just going to do wall dot collider equals static. Don't necessarily need that because the way the algorithm works, it wouldn't be able to go through a wall anyway, but that's up to you what you're doing. Now I'm going to make a tile map, so I need to make myself like that. I could add it to there if I wanted to, it doesn't really matter, but I'm going to say t equals new tiles. Now I've already made my tile map, just like I do in most videos, to make life easier for myself instead of typing out loads of ones, but I will paste this in and show you it. So this is my tile map. You can see I've got a little S there for my start position, and then I've got a couple of routes. I can go this way, or I can go up this middle part. So that's that. And then I just need to define where I'm going to start from. So I'm going to do 25, 25, or I could do tile size divided by 2. That's probably a bit more technical, so let's go for that. Divided by 2, tile size divided by 2, and then how big is each of my tiles going to be, and what's the space and everything, tile size, tile size. So that should now draw us a nice little map. And you see that's my starting position. So this is why P5 Play is so useful, is that I've got quite a lot of work done with not that much code, which is really useful. So there's our little maze to start working with. So the next thing we want to do is essentially mirror this tile map, but with our matrix. So I can just say let matrix, so the local, so I need to declare it up top, I don't use it ever again. And then what this needs to be is an array, or a 2D array of arrays essentially. So again, you'll be able to see it really clearly. Maybe not as clear as this, but a 0 is the path we can walk on, and a 1 is where you can't. Now the only difference to this map is you'll notice that on this line, that there is a 1. So even though there's not a 1 there. Now that's because if I did a pathfind from, let's say, here to here, which I'm going to do, then it's just going to go left rather than go around the map. So even though your actual game might not have a wall there, if you want it to go the long way around, you might put some invisible walls in, or you might not. You know, I could start it from here and get to pathfind to there. It honestly doesn't matter. We can look at that later on. So what we do is we create our matrix. Now there's a couple of ways of doing this. What you can do in P5 Play is set, if I just show you on the website, oh, don't make me log in, so I won't show you it actually, because they've just added a new feature where you've got to log in. So if I go to World, it allows me to log in, and I don't have a login at the moment, so I won't show you that just yet. But what you can do is you can set the whole world's tile size essentially to be 1s. Instead of saying like 100 pixels in, if you say set every pixel to be 50, let's say, it might be that that's 1, 1, that's 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, and so on, which makes it a lot easier when using this pathfinding algorithm. But you can just divide it by the tile size as well, which is what we'll do. Then you don't have to worry about how you draw your objects and things. So I'm going to say, I've already got it up here, so I can say grid equals a new pf dot grid, and I'm going to pass in that matrix that I've just made. Fingers crossed this works. The only reason it wouldn't work is possibly to do with me not installing that library properly. So if we get an error, we know I've messed up. We're good. So I've now got this grid, and I can say let, again it's a local variable, doesn't really matter to be honest, equals a new pf, so pathfind dot a star finder. So what it's going to do is going to pathfind using the A star algorithm. Now there's a bunch you can use. You can use Dijkstra's, you can use best first, breadth first, jump point finder. There's lots of different ones you can use, and I'll demonstrate those in a minute. But we'll just stick with the easy one first. So then we're going to say our path equals finder dot find path. And now what we're going to do is you're going to pass in essentially your start position and your end position. So I'm going to have to do a little bit of maths here, which is I'm going to round down, so floor moving sprite dot x divided by the tile size. So that'll convert, let's say it's 1, because 0, 1, 2, 3, 4, 5, 6, 7, 8. So instead of saying that 200 pixels, it'll know it as 1/8, and that's where it actually is, and that's how the algorithm works. And then so that's the x position. Now I'm doing the same thing, so floor moving sprite. If you don't know what floor is, that rounds it down as well. Dot y divided by tile size. And then where do I want to end up? which is going to be 1, 1. Now what I mean by 1, 1 is 0, 1, 0, 1. So there. Because the way this works, it works on this grid here, not on pixel sizes. So you can, in P5 Play, just divide the whole thing and make it so everything's 1, 1. So if I say move to 1, 1, this will move to 1, 1. You can do that as well. It's entirely up to you. And then the last thing you do is you pass in the thing that you're traversing. So I do that, nothing will happen. It'll just find the path. We don't see anything there. I could console.log it if I wanted to. But now what I'm going to do is I'm going to make another group. So I'm going to say node equals new group. Now this isn't the perfect way. It's not even, you know, the best way or even the easiest way. It's just the way that I've worked this library like to get it to work. So node dot radius equals, doesn't really matter, but I'll say 10. Node dot collider is none. So what I'm doing is I'm making essentially a bunch of sprites. Now these sprites are going to allow us to move around, because what you can do in P5 Play is you can allow a sprite to move towards another sprite. That's why I don't think I actually need visited anymore, to be fair. I think I can actually get rid of that. But essentially what we're going to do is we're going to go ahead and essentially just count our way through each node. Once we've got to the end of the nodes, we've traversed the whole path. So I create that, and then what I'm going to do is I'm just going to loop through the path. So I can say for p of path, and I'm going to say a little local variable that n equals a new node.sprite. I don't necessarily need to make a variable for that, but it's just useful too. And then what I'm going to do is, because this path will be set at 1, 1, 1, 2, I need to convert that back to my tile map. So I'm going to say p0 multiplied by the tile size, so it'll convert it back to my pixel values. Like that. You may want to add a little bit onto there if you need to. We can see how that looks in a second. And then I'm going to add p1. I don't think the bracket's necessarily needed, but it makes it a bit more sensical for us. Like that. So that should make a bunch of new nodes for us that we can see. And hopefully that works for us. Might be a bit dodgy, so we can see. So you see it's slightly off. So all we can do there is just add a little offset. So let's just add 20 pixels to that. And that's just because we are using the 1, 1, 1, 2 like I was saying before. So hopefully now, there we go. There's obviously got my starting position there. It's about right. It's a little bit dodgy, but that is pretty much the path. So we don't need to necessarily see that now, but so we can just do n.visible equals false, and then if I run that now, it's gone, so you can't tell. Okay, so next thing we need to do is get it so we can actually move around the map. So I'm just going to add a clear in there and add a new function called enemy controls. Whatever you want to call it, doesn't really matter, but it's just, I suppose enemy is probably bad. I use it as an enemy in my game. I suppose it's just AI, isn't it? AI controls. So there I can do function AI controls. I think I like capital C better. And then all I'm going to do is, you see at the beginning I had, well, I haven't done that actually yet. So I'm going to make a variable that's called counter. I don't necessarily need to have it here. I could say moving sprite dot counter. So we're going to make it an attribute. Oop, don't want speech marks there. Equals 0. So it's got its own counter, so it knows where it's going. Now what I can do is I can say if, and I'm going to look at the node, so that node group. If I say node, and then I say moving sprite dot counter. Now what this does is this checks if a node exists, because you don't want to start moving to something that doesn't exist. So if I could put equals true as well, but just put if node moving sprite dot counter. That'll be if it exists. Now I can do moving sprite dot move to, and then node moving sprite again, moving sprite like that, dot counter, and then let's make a variable called moving or movement speed, and let's give that a value. So we'll just say let movement speed equals 5. That'll do. So it's going to move towards whatever that value is. So if it's 0, it's going to move to the first node. If it's 1, it'll move to the second node, and so on. And we're just going to say if moving sprite dot overlaps, and then I'm going to say node, and then moving sprite dot counter. Then what we're going to do is we're going to moving sprite dot counter plus equals 1. So we're going to add 1 to that, just like that. And then if it doesn't exist, what this does is it allows us to reset. So let's see if it works. So that's moving along. It's picked the path, and it's got to the end, which is great. So that has got to the end of my map. It's path found from here to there with that as an invisible wall. Now what I can do is I can always take that out now, run it again, and what should happen is it should just move to the left because it's easy. If I change the start position to be, let's say, here, and I'm going to pathfind to the same position, what should happen is it should, I presume, would take this diagonal thing. Yep. But if I block that off, like that, it'll go left. And there we go. So it's doing pathfinding there, which is perfect. That's what we want it to do. So yeah, so I don't think there's much more to cover. That's wet, and that's great. So the next thing you might want to look at are these different types of finders. So what I'm going to do as well is I'm going to make it so we can see this this path again. So we can see the path. Now, what I'm going to do is I'm going to just show you the difference. Not like there is much difference, if I'm honest with you, because a lot of these, because it's not a complex maze, they sort of come up with the same answer really. So I've just popped these in here. Difference between var and let is negligible, so don't worry about that. But if I comment that one out and do Dijkstra's, there won't be a difference, if I'm honest with you. I imagine it do the same thing. But Dijkstra's checks every single one, every single possible location, whereas A* uses heuristics. But I can just go through and you can see some subtle differences. So this jump point finder, which sounds really cool, really spacey, this one will have fewer points compared to the first one. You see it jumps a few points, it cuts your corners almost. But look into those in more detail, it's up to you. There are some more things we can do as well though. So what we can do is we can add in, instead of just doing an A* finder like we did, I can replace this with this bit of code here, which says allow diagonal equals true, don't cross corners equals true. So if I run that now, what you'll see, hopefully when it works, it's slightly different. On my game, my racing game, it was a bit better because there's more corners to cut, but you can see it's sort of like, I can take that out and it'll break because I've not taken that corner off there. But you can choose whether it does diagonals or not. So if I had a bigger corner, so you see here, if I took this out, it'd cut that corner, which is quite good. But if you want to save memory because you've got loads of these nodes, what we can do is we can use this piece of code here. So I'll just pop it here. So if we say let new path equals dot smoothen path, what I can do is instead of that, I can pass in this new path, and what you'll find is with this kind of one, it shouldn't make too much of a difference. But you see, it's reduce the number of nodes because it doesn't need to. Like, it needs a node there to get you around the corner, but it doesn't need a node to go from there to there. It just goes right to the end, so you've got fewer ones. So that's smoothing the path. You can also compress the path as well. So I could do that. And that again does a very similar thing. So I can just leave it like that. And it just reduces the number of nodes, which makes it a little bit more efficient because you're not going to have as many of these. Let's get rid of that first. Don't have as many of these nodes, which might have some sort of performance as you see. It's a fewer amount of nodes. And there we go. There we have it. I mean, it's been quite a long video for such a short demonstration, if I'm honest with you. So it's 20 minutes long. So that's sort of your basics. You can use this sort of any program you want that's got like a maze or like maybe a zombie following you through like a mansion. It's top down shooter that kind of works for. I've used it in combat, as in my combat tutorial, my next one for that. We're going to use this library, racing games, that kind of thing. So it's definitely something to look at. So next video I'm going to show how you can get it so it resets and keeps looping round, as well as having a path that adapts and changes as you go along. But thanks for watching, and I will see you in the next video.